Okay, so this last part is using the normal distribution to find some percents, some proportions, just like we did with the 68, 95, 99.7% rule. But these won't be 68, 95, 99.7. They won't land like, if you read the problem, 450 is not an even number of standard deviations. So how do you do that? All right, so this is where the calculator comes in because we're going to be doing it on the calculator. So when you do these problems, I would like you to do what I am showing you. Okay, I want you to do it the way that I am showing you. A couple of things about the normal distribution. So first of all, you notice the bell curve. I'm going to draw one because we have to draw one anyway. I always, for whatever reason, I do the bottom, like the x-axis kind of. So the bell curve, we always show it kind of hovering over that x-axis, and that's because these are essentially asymptotes. They never cross the x-axis. They never touch the x-axis. So really what you're doing when you are finding these percents, which is basically what we're labeling up here, is you're finding the area below the curve, between the curve and the axis. So if you've taken calculus already, you know what that is. The deal with a normal distribution and these asymptotes is that the area is technically, like, it goes on forever. This graph technically goes off to infinity. There's no stopping point for this graph. The area is not infinite. The area adds up to 100%. I know that's a weird thing to think about, but that is what it is. Okay, so when we do the function in the calculator that we're going to do, sometimes we're going to use essentially infinity. We're not actually going to use infinity, and we'll talk about it when we get to one. So on this question, SAT scores, they give you the mean is 500, standard deviation is 100. You could start labeling this, but 450 and 600. 600 is one of the 68, 95, 99.7 stuff, but 450 is not. So that is the issue, is we need a way to do this. And the way that we're going to use to do this is using the calculator. And if you have taken calculus, what the calculator is doing is an integral. That is what it is doing. And so, but it doesn't matter. You don't have to know what the calculator is doing. So if you haven't taken calculus, it's okay. So we want to find the percent between the percent of the area, or the proportion is a percent. So we want to find a percent between 450 and 600. So the first thing that you typically want to do is graph it, kind of draw it. Okay, 500 is in the middle, so 450 is going to be over here somewhere, and then 600 is going to be over here somewhere. And you could kind of draw them wherever you want, but you know. So this is the area that we're trying to find, is that area. So your percents and proportions are technically an area that you're finding. Okay, so that's what we want to find. The next thing that we want to do is these borders, whether you have two of them or one of them, the next two examples are only going to have one. You need to find z-scores for them. Now this is a little bit of a hold back to older calculators. If you have a newer calculator, one of the rechargeable ones, you technically don't need to do this. But because I don't know which calculators you have, and some people do have older ones, I teach it this way. Also for the AP exam, it's good practice to do these problems this way if you had to do it on a free response, to show all your work. The big thing with the AP exam is showing your work, even for really minor things. So we need to find z-scores. We're going to find z-scores for both 450 and 600. So our data point minus the mean divided by the standard deviation. And when we do that, it's negative 50 over 600. Where is that? Not over 600, over 100. So that's negative 0.5. That's why it was so hard for me to figure out. I was like, divided by 600. Then 600 minus 500 over 100 is 1. Okay? So what we're going to be doing is we're finding the area. Really, if we drew the standardized version of this, we'd have 0 in the middle, and we'd have negative 0.5 and 1. Okay? The function in the calculator that we're going to use, I'm going to write it out here first, is Normalcdf. There are two, it's called cumulative density function, that's what it stands for, and it finds the area between 2 points. There's also a PDF, which is a probability density function. It finds the probability, or the area, it's probability really, at a single point. Finding my people who have taken calculus before know that you can't find the area at a single point. So we don't use PDF, it's 0, but for some functions we will use PDF. It just depends on the distribution. But for a normal distribution, you're finding area under the curve, and the area under a single point doesn't exist. So we're going to look at the calculator. Oh, just kidding. I got to give you the syntax. On the older calculators, this will just pop up when you do it in the menu. So what you're going to do is you're going to type in your two z-scores. You want to do the smaller one first. So you're going to do negative 0.5, comma, the comma is above number 7. You'll see it when we get to the calculator, 1. All right. So let me bring up my calculator. So Normalcdf is under the distribution menu, which is the second vars key. We're going to use distribution menu quite a bit as well. So second vars, that gets you the distribution menu. So the ones that we're going to use today are Normalcdf, and we will use inverse normal. Eventually we will use more of these, but those are the two important ones for today. So we're going to hit Normalcdf. This is a representation of a newer calculator, so you'll see a whole menu. On the older calculators, it'll just come up with Normalcdf. So our lower, that's the smaller of the two numbers, was negative 0.5. Our upper was 1. All right, this, you'll notice it does say mu and sigma, that's the mean and standard deviation, so you could actually change these. The standardized version, if you're using z-scores, you want that to be a 0 and a 1. So you potentially could type in 450 and 600 and change these means and standard deviations, but I want you to find those z-scores. So when I grade on a quiz or test, I want you to find the z-scores, regardless of whether you have a new calculator or an old calculator. Okay, so I'm going to go ahead and hit enter on paste and enter, oops, not enter again. I don't know what I just did. Oh, I think I used the wrong negative. Yep, I used the wrong negative. I was using the keyboard instead of using the keys on the calculator. So it is, our answer is 0.53, so about 53%. You can put your answer as 0.53, or you can say 53%, either way. Okay, but this is what I want to see. I want to see a little graph. I want to see z-scores. You can write out Normalcdf if you want as well. I mean, you need to say somewhere that you're using the normal distribution. So this is the easiest way to do it. All right, so then what happens if you only have one cutoff? So let's look at that. What percentage of all SAT scores are less than 645? So here's our little normal distribution. 500 is right in the middle, so 645 is way over here somewhere. And we want less than 645, so that's going to be this. All right, so we want to find a z-score. 645 minus 500 over 100 is going to be 1.45. And we want, so when we type in Normalcdf, I'm going to abbreviate it now. We need a lower endpoint, so to speak, and an upper endpoint. Our lower one, this goes off to negative infinity. We can't type negative infinity into the calculator, so we're just going to type a big number, so negative 99. Z-scores are typically around 1 or 2. A big z-score would be like 4. So negative 99 is very large, well, very small. Okay, and then our upper boundary, because we need a lower boundary and an upper boundary. Our lower is negative infinity. Our upper is going to be our z-score, 1.45. And so we're going to go to our calculator again, and we're going to do the same thing. Second vars, Normalcdf, and I'm going to do negative, not the minus, negative 99 to 1.45, and get it, and it's 93% about. So 93% are less than 645. And then the last one of these, what proportion are at least 438? At least means 438 or more. So here's what this looks like. Our z-score is 438 minus 500 over 100. That is negative 0.62. Z-score is negative if you're below the mean, positive if you're above the mean. And then on this one, our lower boundary is negative 0.62, but our upper boundary for our area goes on forever. So we're going to say positive infinity or 99. And if we type that into our calculator, we should get about 73%. okay? The last part is going backwards. All right, we're going to have the area. We need to find the cutoff score for it. So here we had cutoff scores. We were trying to find the area. We're going to go backwards. So suppose a college says it admits only people with SAT verbal test scores among the top 10%. How high a score does it take to be eligible? So draw a picture, shade the appropriate regions. So here's our little normal distribution. We want the top 10%. So over here is the high end. So we want this area to be 10%. And we are trying to figure out that value. Okay, so what percentile will we be using? Percentile is the percent below a cutoff. And the reason that the person who wrote these notes is asking this, which wasn't me, is because in the calculator, especially the older ones, the newer ones you can adjust it, you had to have the area to the left of the cutoff. If you have a newer one, technically you can adjust this, but again, I want you to do it in this process. All right, so our percent, if we want the top 10%, that means the opposite of that over here is the bottom 90%. So it's going to be 0.9 or 90%. Okay, so we're finding the 90th percentile. So use the calculator to find the z-score. How we do that is we use the inverse norm function, inverse normal. And you put in, it only needs one thing if you have an older calculator, if you don't have the menu that comes in. You have to put in a decimal thing, but it takes the area to the left. All right, so you need this area to the left. Okay, and we're going to type that into our calculator. Let me show you that. So inverse norm is in the same place as Normalcdf, second bars. It is number 3. And your area you're going to type in is 0.90. It defaults to 0, 1, and left. I would prefer that you leave it that way and just use the area to the left. All right, if you want to figure out how to do it, otherwise you can, I suppose. Oops, I want it. There we go. And press enter, and it's 1.28. Now, obviously, that is not the SAT score. That is a z-score. Okay, and this again needs to be area to the left of your cutoff. So what we have to do is we have to take the z-score and convert it back to an actual SAT score. So we're going to use the z-score formula to do that. Z equals our data point, which we don't know, minus the mean divided by the standard deviation, and we're going to solve for x. So how do we do that? We multiply by 100. As 128 equals x minus 500, and then we add 500. So x is going to be 628. So that is the cutoff score for the top 10% of SAT scores, at least according to this data.